Okay, so my today's topic is about once again regression, but this time I'm not going to talk about linear regression. This time I'm going to talk about the curvilinear regression. In curvilinear regression, we are going to uh, set two different types of trends. One is called the second degree parabola, and another will be known as the exponential curve. And I'm going to show you how to how to set these trends to the given set of data uh, with some calculations, as well as with the help of a Microsoft Excel, and for which I'm going to share my screen with you. First of all, let's discuss about the Excel part, and then I'm going to come to the technical part, which is also very essential to write the program on the given issue. So I hope I am audible to you, all of you, and please you just attentively attend to my class, today's class, because it is also very important section. This regression section is very important. And as I told you in my previous class, that not always uh, the fitting is not always linear. For general data, most of the cases we come across fitting which is having some kind of non-linear trend. Okay, so I'm going to start my screen sharing with you, and for which I'm going to, first of all, I'm going to share the Excel sheet. If my Excel sheet is visible, please, any one of you raise your hand so that I can understand that you can see my Excel sheet. Okay, two people have done so. Okay, so let's start. The data which I have written over here is known to you. This data which is shown over here is actually this particular data was actually used earlier when we studied that correlation coefficient being 0 doesn't necessarily imply that the random variables in the bivariate chart are independent. And you can easily identify the relation between the two variable capital X and capital Y. And the relation, you can also understand, it is kind of parabolic relationship they are having, and it is y equal to x square. First of all, I'm going to draw the diagram, scatter diagram. So I'm going to do as I have shown you earlier. My scatter diagram is, I have obtained my scatter diagram. This is my scatter diagram that I have obtained. Now, after this, we can format the scatter diagram a little bit. Let us change the color so that this is easily visible to all of you. And then I can take my cursor on a particular point. I can select the point. All the points subsequently will be selected. Click the right button of your mouse. Click on Add Trend Line. And previously, what you used to do, you used to choose this particular option, which is linear trend, but the data which is being shown over here, it is a non-linear data, and therefore obviously if I choose this linear trend, the curve will not be an appropriate curve which will contain all the elements present in the bivariate case. So in this particular scenario, since I have already identified that what sort of equation they are having, what sort of relationship they are having between them, I am going to choose this option, a polynomial, and then I'm going to get this sort of curve. And you know that this curve is the y equal to x square curve. Okay. Now, very easily we can fit the data in the following manner. Okay. If the curve is a linear curve, then we can set the linear data. The curve is a curvilinear curve. It is a curvilinear. We have to select the curvilinear button. This curvilinear button can be a logarithmic button, can be an exponential button, can be a polynomial button, whatever it is. Okay. So pretty simple. But what is the mathematics behind it? So I'm going to find out the mathematical analysis of how to fit a curvilinear trend to a given set of data, for which I'm going to share my whiteboard right now. So let's get back to the whiteboard section. And now we have this whiteboard with us, and I'm going to explain the scenario with you mathematically. Now, what is happening over here is that we have this data, capital X and capital Y. I'm going to write the points over here: -1, -2, -3, 1, 2, and 3. And the Y values are 1, 4, 9, 1, 4, 9. Now, suppose the data are arranged in such a manner that we cannot easily identify what sort of polynomial equation or what sort of polynomial relationship they are having between them. So in this case, we are first of all, we are going to put the data in a scatter diagram. We'll try to look at the nature of the scatter plot, and from this, if we can identify any sort of non-linearity hidden inside it, then we can assume an equation of this form. This equation that I'm going to write over here is obviously not a linear equation. So I am actually going to write an equation which is a polynomial of degree 2, and also you can call it a fitting of second degree parabola. Second degree parabola. First of all, I'm going to explain how to fit it, and then I'm going to explain how to choose it. Okay. So how to fit this second degree parabola to the given set of data? If you can recall that in my previous session, we discussed about the linear fitting, which is given by y equal to a plus bx. Now for this fitting, we choose two normal equations. If you can recall, the normal equations were summation y is equal to n into a, where n is the number of items present in the bivariate data, na plus b summation x. And the second equation, normal equation that we actually get, we multiply both the side by xy, and then these terms on both the sides are preceded by a summation. So when we multiply the equation by x from both the sides, we actually get xy is equal to ax plus bx square. And from there, we actually precede these terms by a summation sign. And we get the second normal equation, which is a summation x plus b summation x square. And then we solve this equation, these equations, to find the unknown parameters small a and b. This happens, the entire case is happening for a straight line fitting. We are going to go for a similar approach in this nonlinear fitting also. So we have this equation. First of all, what we are going to do is that we are going to write the terms like this, and all the terms will be preceded by a summation sign. So we'll put a summation sign over there, and you can take the constants outside the summation sign. Their nature is constant, but they are actually unknown. These constants are unknown that we are going to find out in this case. And my first normal equation in this regard is na plus b summation x plus c summation x square, which is equal to summation y. This is my normal equation 1. I denote this by normal 1. There is no such abnormal equation, so don't be afraid. Second, we are going to do is that we are going to multiply all the sides of this equation by x. So we are going to get xy on the left hand side, ax on the right hand side, ax square on the second term, and this term was cx square. So we are going to get x cube over here. Okay, so just a minute. We are going to get cx cube over here. So first of all, we are going to multiply all the terms by x, and then we are going to put the summation sign before that, and we'll get summation xy, a summation x plus b summation x square plus c summation x cube, and that is my normal equation 2. This is my normal equation 2. After that, do I I have to think that do I need to get more normal equations in this case? If yes, then we are going to find the next normal equation. If not, then we will stop over here. But from our basic knowledge of mathematics, we know that we need 3 equations to solve for 3 unknowns. And therefore, one normal equation has been obtained, another normal equation has been obtained, but 3 unknowns are present over here. One unknown is A, another unknown is B, and the third unknown is C. So for this, we need to write another normal equation. This time, what I am going to do is that we are going to write the equation once again. This is my equation. And now I am going to multiply both the sides of the equation by x square. So we get x squared y, ax squared, this was x squared. So I didn't write the x square over here. Just a minute. X squared, a x squared. Yeah, this is x. Sorry. This is not x squared. This is a bx. I am going to multiply by x squared. So what do I get? bx cube and cx to the power 4. Okay. So first of all, I'm going to multiply by x squared, and then I'm going to take a summation. I'm going to apply summation on both the sides. So we get summation x squared y plus a summation x squared plus b summation x cube plus c summation x to the power 4. This I write as normal equation 2, normal equation 3. So all the normal equations have been obtained in the following manner. So if I write all the normal equation with respect to the second degree parabola as we have considered, if we write them together, ultimately what we have got for the given equation of the form y equal to a plus bx plus cx square, we have got 3 normal equation. One is summation y is equal to na plus b summation x plus c summation x squared. Second one is xy is equal to a summation x plus b summation x squared plus c summation x cube. And the third one is x squared y, a summation x squared plus b summation x cube plus c summation x to the power 4. Now, once we get these 3 normal equations, then we are going to make our chart accordingly. As per the requirement of the equation, we are going to calculate the things, substitute them in the equations one after another, and solve the equations to find the values of a, b, and c. I'm going to show that in the next page, and you are going to help me to do the calculation in this regard. Okay. So we are going to make the chart like this. So first of all, we have x and y. The terms are -1, -2, -3, 1, 2, and 3. Then we have 1, 4, 9, 1, 4, 9. First of all, you look at the equation. We need summation y, we need summation x. This can be obtained from the given data itself if we take the summation. Now, what about c x squared? This term is not present directly. So we have to calculate, we have to introduce a column, and which will be your x squared, isn't it? We know that x squared has been written. X squared, this is actually x squared, but remember that we do not know. Suppose we do not know this, that the relation between the two variable is x squared. Here, a simple example has been taken into consideration. That's why we know that. But suppose if I give you a data with 100 elements in it, then we will not be able to immediately tell me that what sort of relationship is present over there. So although we know that it is y equal to x squared, we are going to separately write x squared in the chart. Think that we do not know it, and we are going to find it out. We just want to see whether the calculation works the thing which I have written over here as normal equations, whether it helps us or not. So we need x squared. So we have introduced a column called x squared. What else do we need? We need x cube. We need x to the power 4. So subsequently, we are going to introduce these columns also. So we need x cube. We need x to the power 4. What else do we need? We need, from look at the left hand side, we need xy. We need x squared y. Okay. So introduce this xy, this column, and x squared y, this column also. These columns are being introduced over here just by looking at the form of the normal equations given. So x squared is pretty simple. We can easily put it like this. And we know that this is actually nothing but equal to this relation. Okay. So actually, immediately we can say that, yeah, y equal to x squared, no problem with that. But still, we actually want to know whether it is coming from the normal equation or not. That we want to check. So this problem, you can say that it is just for a checking purpose. It could have been much easier if I take another problem, but in that case, I have to change my data, and right now any other data is not available. I think if I do the problem, if I solve this particular calculation, then I think it should be very meaningless if I proceed with the given calculation, because after calculating x squared, it is we already know that it is what kind of relationship we are going to get. So let us not apply this particular methodology to the given set of data. It will be a kind of stupid kind of thing that will happen over here. So let me change the data, and let me give you another data which I can find from the exercise of the book. So I think it would be much better if I consider this. Immediately, you cannot say that what sort of relationship they are having between them. Okay, and later we can easily try to look at the curves they are actually showing to us. So we have 1, 1, 2, 2, 3, 3, 4, 5, 6, 7. Okay, I'm choosing this, and 1 goes to 2, and this is related to 7. Corresponding to that, I'm getting 7. Corresponding to that, I'm getting 10. Then this is 8. This is 12. This is 10. This is 14. This is 11, and this is 14. Okay, so I think it would be much better if I work with this data. Now, then you can recalculate your, this column headings will remain same. There will be no change, but we have to recalculate the x squared value, x cube value, etc. Now you see that x squared is coming out to be what? It is 1. It is coming out as 1. This is coming out as 4. This is coming out as 4. This x here, this x squared is 9. This x squared is 9. This is 16. This is 25. This is 36. And this is 49. You can now check the differences between y and x. At least we can say that y is not equal to x squared. They are different now. So I think it would be much better if I stick to that. So all the square terms have been calculated. Now you go for the cube term. So we have this 1, this is 1, this is 8, this is 8, 27, 27, 64, 125, and this is 216, isn't it? 216, and that is how much? That is 343. And similarly, rest I'm going to leave. I'm going to leave this remaining calculation for you to do. You try to find out all the values from here. All these values, x to the power 4, xy, x square y, all these you do try to find out. And then what you can do, you can find the summation of these columns. So the summations that is needed is summation x, summation which is needed is summation y, and that is summation x square. From there you will get summation x square. From there you will get, we are going to get summation x cube. Then you are going to get summation x to the power 4, summation xy, and summation x squared y. All these summation you are going to get from the calculated columns. And after that, you are going to put all the summations in the normal equations subsequently. I am just going to check. So you just write the things in your copy, and I am just going to check whether what sort of curve this is showing with respect to the given. This particular data is actually showing us. Okay, I'm going to look at this. I hope that you have copied the bivariate table. I'm going to stop the share and I'm going to get back to the Excel sheet and try to look at the sort of curve that is actually being will be shown by the given set. Okay, so I think it's deleted, and let us input. Let us give the input. This data as input. Sorry. So you just do the calculation, because the Excel is not going to show you the calculation. It is just going to give you the type of curve it is showing. It is having. So we have 1, 1, 2, 2, 3, 3, and then we have 4, 5, 6, 7. Okay, and the y values were 2, 7, 7, 10, 8, 12, 10, 14, 11, and 14. At least what I can do, I can help you to find out the columns, or I can help you to find the columns, the values of the different columns. Okay. So we have this xy. First of all, we are going to calculate this x square. Okay. Oh, first of all, let us try to check what sort of curve it is showing. Because immediately we cannot, yeah, this is the thing. This is very, it's a non-linear curve, and it is not at all a parabolic curve. So what sort of curve By looking at the diagram, we are unable to guess it. What sort of relationship the variables can have between them. It is very difficult to guess. Okay. So first of all, let us try to calculate the things which are needed to find out the equation manually. So these are the things I'm going to try to help you in this regard. So these are the columns that is needed for the purpose. Just a minute. We need this x. Sorry, let us write it in bracket x squared and then y. Okay, x squared y, xy, x4. Okay. Now, and I'm going to calculate these things. So this will be the square of these terms. Cube of this will be the cube of this x terms, that is x multiplied by x squared. This part will be fourth power of the x terms. So x will be multiplied by x cube. This will be the multiplication of the first two columns. Okay, and that will be the multiplication of the columns, second column and the third column. So all the column values have been calculated in this manner. Also, I can try to help you to find out the summation of these columns respectively. So this is summation x. Okay, and the next one will be summation y. This will be summation x cube, x square. This will be summation x cube. This will be summation x to the power 4. This will be summation xy. And this will be summation x squared y. So all the summations have been calculated. Okay. Now try to recall the normal equation that you have with you. Normal equation is this. We have summation y n into a plus b summation x plus c summation x squared. Second normal equation was xy a summation x plus b summation x squared plus c summation x cube. And the third normal equation was x squared y plus a summation x squared plus b summation x cube plus c summation x to the power 4. Now you are going to take the pain to substitute all the summations in this particular equations, and you have to solve it for a, b, and c. So try to find out a, b, and c from the given by solving the given set of equations. I am not asking you to do it right now because I know that it will be pretty much difficult for you to do it. because things are too large in this case, and therefore that is why actually I wanted to take a pretty easy example from which were written earlier in the board. But probably we are laughing then that sir knows the relation, but he is trying to forcefully find out the relation by doing these unnecessary calculations. That's why I wanted to do that problem, just to show you the technicality that yes, it comes out. Now you have to take the pain to substitute the values, and then you are going to solve the equation to find what are the values of A, B, and C. But before that, before I close this particular page, I can at least check what sort of curve it is showing in this particular, with respect to this particular data. So as before, we can choose this polynomial curve, a second degree polynomial curve. You can change the degree of the polynomial by choosing this button. So if here it is written order, by in Excel sheet by this key order, it is actually meaning the degree. I do not know why they have written the order. By it should have been degree, but you can increase or decrease the order of the curve. Okay. Now, if I click on it, this sort of relationship will come out of it. So this is the relationship that you are going to get. You are to check whether this relation is indeed obtained, for the calculation of the given set of data, whether you are going to get this equation or not. That can only be checked if you solve the system of equation and try to find out what are the values of A, B, and C. So here it is, I don't know why it is not enlarging. It is minus 0.269. This is 3.8482. This is the value of B. And for the value of C, we have, no, sorry. The value of A is this one, 1.802. Because our form is A plus BX plus CX squared. So value of A is this one, value of B is this one, and value of C is this one. What will happen if I want to change, the order degree of the data? Let us try to find it out. If I want to choose a polynomial and if I change the degree, what comes out? If I use a cubic polynomial, let us try to find out what comes. Now this comes. For cubic polynomial, this comes. You see? Now in various way, you can find out the given you can fit various kinds of polynomial to the given set of data in this particular regard. But in our case, in the curve fitting, only we have the second degree parabola fitting. The cubic fitting is not there. But if you had, suppose you had the cubic fitting, then what would you have done? The same kind of logic will be applied over in this particular case. We will have to consider the cubic equation of this form. Okay. Then first of all, you have to precede all the terms by summation y, summation. So we have to write it as summation y, na b summation x plus c summation x square plus d summation x to the power 4. And then you have to multiply this. If this is equation 1, then you have to multiply equation 1 by, first of all, x, precede this by summation, multiplied equation 1 by x square, preceded by summation, multiply equation 1 by x cube, precede this by summation. In this manner, you are going to get 4 equations and you have to find it out. But finding 4 equations for 4 unknowns is not a very easy matter to do, for which you know very well that some other type of things are required, some other type of knowledge is required, and that knowledge is actually the abstract algebra, not linear algebra, because we are not dealing with linear curves over here. So I'm not going into the detail of that. So this is how a curvilinear trend is fit to the given set of data. And after that, what you can do, we can do one thing. Once you find this, if you find this relation, if you find this relation over here as has been given, this relation, then what you can do is that you can put the you can estimate the value of y. You can put the estimate of value of y over here, and you can find out what are the differences between the value y and their estimates. That calculation can also be checked. So okay, I'm stopping over here. Let us continue in the next session.